Hello and welcome to chapter 4.6. This will be the last one of chapter 4, and we're talking about rational functions. So our objective here is to find the domain, asymptotes, and graph rational functions. A function is rational if my function has a numerator and denominator that are each polynomials. And d of x, so my denominator cannot be 0 and is not a constant. Okay, so it's some kind of equation, polynomial equation with x in it. Okay, so we've kind of focused a little bit ago about finding the domain. Okay, and in this case, my domain here, the problems occur down here in this denominator. Okay, these excuse me, these numbers cannot be 0. So what we'll do is we'll say x squared minus x minus 6 cannot equal 0, and we'll factor this. So factors of 6 that subtract a 1 are 3 and 2, x, signs are different, and the bigger one is minus. So minus 3 plus 2. Okay, so then I set both of these not equal to 0. So x cannot equal minus 2 or 3. And we want to write that as interval notation. So we start with the whole interval, negative infinity to infinity. We start with that. And I got to pluck out these two numbers. Okay, so we'll go negative infinity to minus 2 union 2 to 3. Sorry, that's a minus 2. To 3 union 3 to infinity. Okay. So I can include any number except those two numbers. And I believe we've done this a little bit before. Okay, so we're not worried about this top here when we find domain. Okay, I'm only worried about the bottom because the top can be anything. So we set this bottom cannot equal 0. And we say x squared plus 9 cannot equal 0. Okay. And if I solve this, I got x squared cannot equal minus 9, square root, x cannot equal plus minus 3i. Okay. Well, if you look at that, these are two imaginary numbers. I don't normally pick imaginary numbers. So we like to deal with real numbers. So we'll just say that I can pick any real number. Okay, which is the truth. All right, so that's a little bit on domain. Okay, and notice here, I know we've talked about this before also. We want to do it before we cancel because this does not equal x minus 2. Okay, and in fact, if I factor this here, that's x plus 2, x minus 2, over x plus 2. Okay. X still cannot be minus 2. Okay, even though those cancel and I get x minus 2, I have to add in here x cannot be minus 2. Okay, now they're the same. Okay. This creates a hole on my graph, and we'll talk about that here in just a little bit. So vertical asymptotes. If f of x, I got my numerator and denominator, is in lowest terms, where d of x, then where d of x equals 0, so where my bottom equals 0 creates a vertical asymptote. If not in lowest terms, then whatever cancels creates a hole. So like up here, this was not in lowest terms. So this creates a hole on my graph. If it was in lowest terms, I would have a vertical asymptote at, let's say, minus 2. So that's that imaginary vertical line that my graph maybe can't pass. Something like that. I don't know. Okay, there's a vertical line there that I cannot cross. Okay, so locate the vertical asymptotes. So again, we're going to factor everything that I can. So we need to factor this bottom. So I got 6 times 2 is 12. Little rainbow method here. Factors of 12 that subtract to 1, 4 and 3. So we'll break down 6, 1, 2, 3, 1, 2. So I got to use 1 and 2, and then 2 and 3 to get my 4 and 3. So on the top, I still have 5x plus 2. On the bottom here, I'll have 2x and 3x. I took 2 times 2 to get my 4. And I took my 3 times the 1 to get the 3. Signs are different. The bigger one is negative, so 4 has to be negative there. So that goes with the 2 and the plus. Okay. So the reason I do this is because it has to be in lowest terms, which it is in lowest terms. So then my vertical asymptotes are when these equal 0. Okay, it's just your domain. So we'll say 2x plus 1 equals 0, and 3x minus 2 equals 0. So I'll subtract 1. 2x equals minus 1. Divide by 2. Divide by 2. X is minus a half. There's one vertical asymptote. And add 2, divide by 3. So x is 2/3 is another vertical asymptote. So I've got this graph here with minus a half. So there's 1. There's positive 1, minus 1, and 2/3. So I've got two vertical asymptotes there that my graph cannot cross. And we'll talk about more about how do I know where that graph is. Okay, locate vertical asymptotes. Again, we want to factor everything if we can. So we'll start here, x plus 2 on the top. We can factor out an x out of the bottom. We get x squared minus 3x minus 10. Factors of 10 that subtract to 3. That would be 2 and 5. Okay, signs are different. The bigger one is negative. Okay. Now notice here that I can cancel. So since it is not in lowest terms, we're going to put it in lowest terms, and we're going to say x over x minus 5, where x cannot equal minus 2 from this part right here. Now, that does not create a vertical asymptote. That just creates some hole in my graph. So wherever negative 2 is on my graph, I have to have an open circle. Okay. So here I have x and x minus 5. So x equals 0 is a vertical asymptote, and x equals 5 is a vertical asymptote. Here we'll say cannot equal 2. Okay. Now with vertical asymptotes, okay, I probably need to go back here to this picture here and explain this a little bit better. It is approaching that asymptote. Okay, it is getting really, really close to that asymptote. Whereas with this doesn't equal minus 2, okay, I have just some open circle there. Okay, so it approaches that number and then skips it and keeps going. But with some vertical asymptote, okay, let's just do another one here. Let's say I got an asymptote there. A vertical asymptote, we're going and we are approaching that very, very closely. Okay, it gets closer and closer and closer to that vertical line. So with horizontal asymptotes, again, we have our numerator and denominator. Okay, and when the degree, these are degrees, when the degree of the numerator is less than the denominator, okay, I probably could have changed that to a D. Okay, those are degrees. When the numerator degree is less than the denominator degree, we have y equals 0 is my horizontal line. Okay? That would be just something like this. If I got that. This right here is my vertical or my horizontal asymptote. It won't cross that. When they are equal in degrees, you have an over bm. These are your leading coefficients. Okay, so y equals your leading coefficients over each other will be your line. So let's just say we got the horizontal asymptote like that. And maybe my line approaches like this. Okay. I might have a hole right there instead of a straight on asymptote. And when n is bigger than d, okay, when your numerator has a degree bigger than your denominator, you don't have a horizontal asymptote. Okay, so we need to keep this handy here while we're doing some of these. So to determine the type of horizontal asymptote, and then what is the horizontal asymptote? Okay, so we notice here that my numerator is less than my denominator, the degrees. This has degree 1, this has degree 2. So when that happens, when your degree of the numerator is less than the denominator, you have your line y equals 0 is your horizontal asymptote, which is just the x-axis. So if we graph this out real quick, so if I have 8x plus 3 divided by 4x squared plus 1, if I graph that out, notice there I've got that horizontal asymptote. Let's just assume standard. I cannot cross that line. Now here it looks like we've crossed there, but there's probably a hole right there. Okay, so there's my asymptote. Here we've got our degrees are the same, so n equals d. So in that case, we're going to have y equals my leading coefficients over each other. So we have the line y equals 2 is my horizontal asymptote. Again, if we just want to take a look at that, we have 8x squared plus 3 divided by 4x squared plus 1. And if we graph that out, notice I do not cross that y equals 2 line. And the last one, our numerator is bigger than our denominator in degrees. Okay, so when the numerator's degree is bigger than the denominator, we do not have an asymptote. So there is none on that one. Slant asymptotes are where things get a little bit tricky. Okay, so if we so we've got our polynomial here, numerator and denominator, and the degree of the numerator is 1 more than the denominator. Okay, so this might be x to the third, and this is x squared. They're 1 different. Then the slant asymptote is q of x after the division. Okay, so you're gonna have to do long division with it. Okay, and you will get f of x equals q of x plus whatever your remainder is. You'll get a remainder sometimes. This is my answer, and it will be some linear equation. And that is my slant asymptote. Slant asymptote is just some line that we might not ever cross. Okay, so I'd never cross that line right there. Okay, so find the slant asymptote for this function here. So we notice that they are 1 degree off. Okay. So what we're going to do is we're going to divide the two. Divided by x minus 2. And you might say, well, can't we do synthetic division? Yes, you can do synthetic division with that, but we want to get in the habit of looking at this in long division, okay, because it's not always going to be that way. So how do I make x become x squared? We'll multiply by x, we get x squared minus 2x. We subtract, those cancel. We get 5x, bring down the 2. Multiply by 5x, you get 5x minus 10. subtract, those cancel, and you get 12. So then you get plus 12 over x minus 2. Now, I don't care about this part. This is my slant asymptote. So y equals x plus 5 is your slant asymptote. That's the important part. Okay, we can look at another one here real quick. Let's look at f of x equals 4x to the third plus x squared plus 3 over x squared minus x plus 1. Okay, again, these differ in 1. So we're going to say x squared minus x plus 1 divided into 4x to the third plus x squared plus 0x plus 3. Don't forget your placeholder. So x squared to 4x to the third, we need 4x. So we got 4x squared minus 4x. Oh, that's to the third, that's squared. Plus 4x. Subtract. Cancel. You get 5x squared minus 4x plus 3. And then we'll have a plus 5. So you get 5x squared. Kind of running out of room here. Minus 5x plus 5. And subtract. Those will cancel. You get x minus 2. So plus x minus 2 over x squared minus x plus 1. Now again, the remainder doesn't matter. This is your slant asymptote. So if I were to graph this, 4x to the third plus x squared plus 3 divided by x squared minus x plus 1. Kind of hard to see, but you have a line there. And if I graph that line, it can kind of be hard to see. But I've got this line right here. Let me zoom in just a little bit and get out of that glare there. So there's my function. And I've got this line that as I keep approaching its endpoints, I keep getting closer and closer and closer to that line. Okay. We'll stop 4.6 here. We'll continue with how to graph these rational functions in the second part. So I've got some suggested problems here in the green, the 5, 9, 11, 15, and 21 that you can go ahead and give a try. Here's part 2. That will be on the next video. So as always, thanks for watching. Go ahead and subscribe if you want. Like it, give me a comment, give me a shout out. As always, this is at THS Mr. Jones signing off.